So let's go now to the Radiotap API and its iterator to access the content. Radiotap adds some headers to your frame with many information. For indoor positioning systems, what we find useful is the dBm RSSI value, the dBm noise value, the channel which the packets come from, and the antenna on which it was received. First, you can try to access to the raw header, which is an array of bytes. So the first part of the header is a structure with its version, which is always 0, some padding, then the Radiotap header length, and the presence flags. You must read radiotap.h file for more information. The header flags, which is named itpresent, is on 32 bits, and with the last bit extending the flags field to 32 more bits, and so on. So the extended flag field can have the last bit to 1, which means you have even more 32 more bits. Each flag, which is a bit, tells of the existence of one type of information in the header, and its size depends on the type of information, which is also defined in some header files in the development include directory. So to get information from the Radiotap header, you have to go through it sequentially to be able to find the good offset of your information given the values of the flags in the itpresent bits. So getting a given field from Radiotap, you start with a pointer to the Radiotap header. First, you check the version. If it's not 0, it means it's not Radiotap, so you got to a wrong packet. Then you get the length, and you have to parse the flags, so use mask or bit shifting, it's okay. For each bit set, you add the corresponding field offset to the offset to what you need. So if you want the 4th field and you have 2 fields before, you have to jump over the 2 first fields, so you compute their offset. You continue until you reach the end of the flags. Do not forget to add the flag fields and the Radiotap header size to the offset, because they are also in your array of bytes. So for instance, here we want to find the RSI dBm signal. So everything takes place in our pcap callback. We have radiotap.h, pcap.h, and cstdlib for some information such as I don't remember which one. I don't remember. Whatever. So you convert your bytes in a rtap header, Radiotap header. You have the fields length which are up to the RSI field. You check the version. If it's okay, you offset to the size of the Radiotap header structure. Then you cast flags as an unsigned int with this address, and you try, while the flag is 1, you add 4 to the flag size and 4 to the offset. So it's if you have extended flags. Then you start with the first bit of the flag and you try to find the Radiotap dBm end signal. You go from 0 to this one. If you have your flag equal to 1, then you add to the offset the size corresponding here. And at the end, you get the RSI, which is the size of, which is at the location of the offset. So it's quite tedious and prone to errors to use manual access to Radiotap fields, because it's easy to forget some offset and so on, due to the dynamic header size and composition. So what can be useful is to use the library Radiotap iter, which hides the inner complexity while still allowing full access to the Radiotap header content through iterators. So here you see you include Radiotap iter.h. You have your iterator, which is struct i3 80211 Radiotap iterator. You have your header as a pointer, the packet size. To init, you use i3 80211 Radiotap iterator init. You pass the address of the iterator, the AirTap header, the packet size, and null better, because the last argument is not interesting for us now. Then to go through fields, you try while the Radiotap iterator next is 0. You try this, the value of this arg index, which defines what type of information you have in the current data pointed by the iterator. So we switch over it and we have cases, and case i3 80211 Radiotap dBm end signal, which is the RSSI value. Then here we do something with this arg, which contains the RSSI value that we can store somewhere to use for the positioning system. So here an example to extract RSSI. We have our bytes, we check the version, we initialize the iterator, and if it's okay, we go through all the items accessible with the iterator, and if it's the RSI signal, we output it to the screen, simply as that. So, to extract Wi-Fi information after handling Radiotap, which is the first part of the frame captured, you have a max length in Radiotap iter, which contains the full size of the Radiotap header. Then you jump to the next byte, which is the max length byte captured, and there you start the i3 802.11 header, which is the layer 2 header in which you have the MAC addresses. You read to DS and from DS flags and extract the corresponding MAC addresses. A quick example is here. You process the packets, so you have the Radiotap header, you check the version, you initialize the iterator, you find the RSSI value, and at the end of the Radiotap header, so it's here, you compute its offset, you find both flags for 2DS and from DS. We filter to have only frames from the mobile client to the access points. Then we try to get the RSSI.